Good morning, students. Today I am going to revise bond polarization and types of organic reagents. Uh, Organic chemistry. What is organic chemistry? Organic chemistry is nothing but the study of hydrocarbons and their derivatives. Study of hydrocarbons and their derivatives. Then what is meant by hydrocarbons? Hydrocarbons are the compounds of carbon and hydrogen. Exclusively carbon and hydrogen are present in the compound. That compound is known as hydrocarbon, and the study of these hydrocarbons and their derivatives. That is, the compounds which are obtained from these hydrocarbons are called their derivatives. The study of these hydrocarbons and their derivatives is known as organic chemistry. The age of organic chemistry. Then why we said like this? Because the three basic needs of human are food, clothing, and shelter, which are made up of organic compounds. Most of the medicines that cure diseases and relieve pain are all organic compounds. The LPG or cooking gas is a mixture of butane, isobutane, and to some extent methane. And gasoline propels the automobiles, the plastics, the rubber. These are all organic compounds which we use in our day-to-day life. So basic needs of humans are food, clothing, and shelter. These are made up of organic compounds, we said. So because of this reason, organic chemistry is more important. And in this basic needs, we come across all these medicines, LPG, gas, gasoline, plastics, rubber, etc. All these, they come under important organic compounds, which we daily use. So this is structural theory, our topic, structural theory, it gives a better understanding about the basic organic chemistry. So mostly organic compounds are covalent compounds because carbon generally forms covalent bonds. Now let's discuss about the types of the bonds formed by carbon. That is the types of the bonds we come across in the organic chemistry. So let's discuss about this covalent bond. So covalent bond is a chemical bond which is formed due to equal contribution and mutual sharing of electrons. So this is the definition of covalent bond. So what does it say? According to the definition, covalent bond is formed due to equal contribution of electrons and mutual sharing of electrons. Two atoms will participate in the covalent bond formation. This covalent bond is of two types. It is of three types, sorry. So first one is single bond, second one is double bond, third one is triple bond. The single bond is also called single covalent bond, and double bond is also called double covalent bond. Triple bond is also called triple covalent bond. Now let's discuss about all these types of covalent bonds in detail. There, the first one is single bond or single covalent bond. So what is single bond or single covalent bond? Let us discuss first. Single bond is that is, when one pair of electrons are shared between the two atoms, then that bond formed is known as single bond or single covalent bond. The best example for the single bond is hydrogen molecule. Generally, single bond is denoted by a small dash in between the two atoms. Now let's discuss about this. Let's consider one general example. Two atoms A and B. A contributes one electron and B also contributes one electron. And both these atoms, they share this one electron pair. Thus, a molecule AB is formed, that is denoted like this. So, a covalent bond is formed in between the A and B atoms, that is denoted by a small dash in between the two atoms, that is AB. So here AB molecule is formed due to equal contribution of electrons and mutual sharing of electrons between A and B atoms. Thus AB molecule is formed. This AB molecule has one covalent bond, that is single covalent bond, which is denoted by a small dash in between the two atoms. The best example, the simplest example we can explain for single covalent bond is hydrogen molecule. Now, one hydrogen atom contributes one electron, another hydrogen atom also contributes one electron, and this two electrons, that is a pair of electrons, are shared between the two atoms two hydrogen atoms. Thus, H2 molecule is formed. That is denoted by H dash H. This dash is simple dash, a small dash in between these two hydrogen atoms is nothing but a single covalent bond. So this is about single covalent bond. If we consider methane molecule, there are four single bonds, four in between C and H, four single bonds are present. If we consider H2O molecule, in between oxygen and two hydrogen atoms, two single bonds are present. Similarly, if we consider ammonia molecule, in between nitrogen and hydrogen, single bond is present. So like that, these are all the different examples where single covalent bonds are present. Now, let's discuss about the double bond or double covalent bond. Double bond or double covalent bond. A double bond is formed when two pairs of electrons are shared between two atoms and it is represented by two dashes in between the two atoms. So, double bond is formed due to the equal contribution and mutual sharing of two electron pairs. Two electron pairs are shared between the two atoms. Then it is a double covalent bond is formed that is represented by a double dash in between the two atoms. Now let's consider few examples. They are the first and the simplest example is oxygen molecule. In between two oxygen atoms, there is a double bond. There is a double bond. This oxygen atom pairs are shared between the two oxygen atoms. Thus, O2 molecule is formed. In this O2 molecule, there is a double covalent bond in between the two oxygen atoms. Similarly, the other examples are carbon dioxide, where in between carbon and oxygen a double bond is present. This side also carbon and oxygen a double bond is present. Double covalent bond or double bond. Similarly, another example is ethylene molecule, that is CH2 double bond CH2, that is in between two carbon atoms there is a double bond. So this is about a double bond or double covalent bond. Now let's consider triple bond or triple covalent bond. A triple bond, a triple covalent bond. It is formed when three pairs of electrons are shared between the two atoms and it is represented by three dashes in between the two atoms. A triple bond is formed when three electron pairs are shared between the two atoms. That is, equal contribution and mutual sharing of three electron pairs leads to the formation of a triple bond, we can say simply. And this is denoted by three dashes in between the two atoms. Here, let's consider the examples. The simplest example is nitrogen. In between two nitrogen atoms, there is a triple bond. This nitrogen atom contributes 3 electrons and this nitrogen atom also contributes 3 electrons, and these 3 electron pairs are equally shared, mutually shared between the two nitrogen atoms. Thus, N2 molecule is formed. Thus, it is represented by N triple bond N. This is the triple covalent bond which is present in between the two nitrogen atoms. And other examples we come across the carbon monoxide, that is in between carbon and oxygen there is a triple bond. And one more example is acetylene molecule, that is CH triple bond CH. In between two carbon atoms there is a triple covalent bond. This is one more good example for triple covalent bond. So, till now we have discussed about the three types of the covalent bonds formed by carbon. Generally, carbon, it forms three types of the covalent bonds. There, the first one is a single covalent bond, and the next one is double covalent bond. Third one is triple covalent bond. A triple bond. Single covalent bond is formed when a pair of electrons are shared between the two atoms, and double covalent bond is formed when two pairs of electrons are shared between the two atoms, and triple covalent bond is formed when three pairs of electrons are shared between the two atoms. Now let's discuss about the types of bond fission. So, types of bond fission. So, what is bond fission? Bond fission is defined as breaking of existing bonds in the reacting molecules. Generally, in the organic chemistry, or in this organic chemistry, what happens? The breaking up of the bonds and making up of the bonds takes place to form new molecules. So, breaking up of the bonds is only known as bond fission. Bond fission. So, in the existing reacting molecules, the old bonds must be broken and then only new bonds will be formed in the products. So, here, the breaking up of existing bonds in the reacting molecules is known as bond fission. This is definition of bond fission. And there are two types of bond fission. There, the first one is homolytic fission and second one is heterolytic fission. So, what is bond fission? Bond fission is defined as breaking of existing bonds in the reacting molecules. And this bond fission is of how many types? It is of two types. There, the first one is homolytic fission. Second one is heterolytic fission. Now, let's discuss about each type of the bond fission in detail. First of all, let's discuss about homolytic bond fission. Homolytic bond fission. This homolytic bond fission, if the bond pair of electrons goes with both the bonded atoms, then it is called homolytic fission. That is, during the homolytic bond fission, what happens? In the pair of electrons, that is the two electrons, they are equally distributed to both the atoms. Then it is known as homolytic bond fission. So, due to homolytic bond fission, free radicals are produced. That is, homolytic bond fission results in the formation of free radicals. Whenever homolytic bond fission takes place in a molecule, free radicals are produced. Then what is a free radical? Free radicals are nothing but the single electron or odd electron species, or the species or the atom with unpaired electron is known as free radical. I'll repeat. Free radicals are nothing but these are the atoms or group of atoms which have either one electron or single electron or unpaired electron. These are only called free radicals. Now, this when this homolytic bond fission takes place, that is, this homolytic bond fission takes place when two bonded atoms have same electronegativity. That is, if the two atoms having the same electronegativity, then the bond fission taking place in between the two atoms is only homolytic bond fission. So, homolytic bond fission, in homolytic bond fission, what happens? The two atoms which participate in the bond uh, with the two electrons which participate in the bond formation, they are equally distributed to both the atoms which are present in the molecule. Thus, we get free radicals, and this happens when the electronegativity of both the atoms present in the molecule is same. This is how let's explain this homolytic bond taking different examples. So, example here, homolytic fission, generally it is denoted by, it is represented by, let me say, fish hook arrow. Fish hook arrow. This is fish hook arrow. This is a curved arrow with one line here. So, half arrow it is called. So, this is known as fish hook arrow. Fish hook arrow is used to represent homolytic bond fission. Now, let's discuss about the example here. Let's consider one molecule AB, which is made up of two electrons. A single bond is nothing but made up of two electrons. Now, the bond fission takes place, a homolytic bond fission. If it takes place in this molecule, what happens? One electron of this bond goes to B, another electron of this bond goes to A. Thus, we get A dot plus B dot. Dot is nothing but an electron here. So, A dot plus B dot. So, these are known as free radicals. What is free radical? We said free radical is nothing but the atom or group of atoms having unpaired electron or odd electron or single electron. So, here A is a free radical, here B is also a. So, let's discuss homolytic fission taking the specific example of chlorine molecule. Here, chlorine molecule, it is made up of two electrons. This is single bond, single covalent bond, that is made up of two electrons. Now, the homolytic bond takes place here. What happens? One electron goes with one chlorine atom, another electron goes with another chlorine atom. Thus, we get two chlorine free radicals. Here, star. Star is also nothing but an odd electron, let me say. Odd electron can be represented by a dot or a star. So, here, chlorine free radical, another chlorine free radical. Now, next example, let us see. This is hydrogen molecule, H2 molecule, which is made up of two electrons. The single covalent bond made up of two electrons. When it is homolytically broken, then what happens? So, two hydrogen atoms, they get one electron each. Thus, we get two hydrogen free radicals. And next, one more example we considered here, that is bromine molecule. And between the two bromine atoms, there is a single covalent bond which is made up of two electrons. When this covalent bond is broken homolytically, then what happens? Each bromine atom gets one electron. Thus, we get two bromine free radicals. This is bromine free radical, another bromine free radical. So, these are the different examples for homolytic bond fission. So, what is meant by homolytic bond fission? We said homolytic bond fission, it is nothing but the bond fission where the bond pair of electrons, they go with the bonded atoms. The bond pair of electrons, they goes one pair of electrons, the pair of electrons, they goes with the both the bonded atoms, then it is called homolytic fission. So, due to homolytic fission, what happens? We get free radicals. So, what is a free radical? We said free radicals are nothing but the atom or group of atoms. Group of atoms is also known as species. The atom or the species with odd electron or unpaired electron or free electron. That is only known as free radical. And generally free radicals are highly reactive because they possess odd electron. So generally whenever this homolytic bond fission takes place, we said the homolytic bond fission, it takes place when two bonded atoms have same electronegativity. Same electronegativity. Now, examples we have discussed here. Chlorine, both the chlorine atoms, they have same electronegativity. And they have same electronegativity. Whenever such type of atoms have same electronegativity, then the is producing free radicals. So what is a free radical? We said free radical is nothing but the atom or group of atoms are the species with single electron or odd electron or unpaired electron. Generally, due to the presence of this unpaired electron, free radicals are highly reactive. Free radicals are highly reactive. And generally, homolytic bond fission is represented by a fish hook arrow. This one, fish hook arrow. This is curved arrow, half arrow. That is known as fish hook arrow. This is about homolytic bond fission. Now let's discuss about another bond fission, that is heterolytic bond fission. Now let's discuss about heterolytic bond fission. So heterolytic bond fission, if the bond pair of electrons goes with any one of the bonded atom, then it is called heterolytic bond fission. Heterolytic fission. In heterolytic bond fission results in the formation of ions, that is positive and negative ions. It takes place when two bonded atoms are having different electronegativities. So whenever in between the two atoms, the electronegativity difference is more, then what happens? Heterolytic bond fission takes place. Heterolytic bond fission, let's discuss here. Heterolytic bond fission, it is generally shown by a curved full arrow. This is normal arrow, let me say. Now, let's take an example, general example of AB. In between A and B, there is a covalent bond which is made up of two electrons, single transfer both the electrons towards one atom. The other atom becomes a positively charged ion, and this atom with the pair of electrons becomes a negatively charged ion. Then why this B is becoming negative ion and A is becoming positive ion means B is more electronegative than A. When B is more electronegative than A, then what happens? The bond pair of electrons, they go with the B atom. Thus, B becomes a negatively charged ion and A gets the positive charge. And this is a positively charged ion. In the other way, here what happens, if the bond pair of electrons, they go with this A atom, then what happens? A becomes negatively charged ion and B becomes the positively charged ion. Why the pair of electrons are going with A? Because here A is more electronegative than B. This is how the heterolytic bond fission takes place. Heterolytic bond fission in the sense, The pair of electrons of a covalent bond, both will go with only one atom. The other atom suffers with a positive charge. Here, these positive and negatively charged ions produced during the heterolytic bond fission of a covalent bond present in the organic molecules results in the formation of ions. Positive ions which are produced during the heterolytic fission are called electrophiles, and the negatively charged ions which are produced during heterolytic bond fission are called nucleophiles. So what are these here? Two types of ions are produced during the heterolytic bond fission. Positively charged ions are called electrophiles and negatively charged ions are called nucleophiles. Now let's consider the simplest example. Here we did not consider the carbon compound. As the simplest example I have taken, that is HCl molecule. If this in this HCl molecule, if the bond pair of electrons are moving towards chlorine, because chlorine is more electronegative, then what happens? We will get Cl minus ion and H plus ion. Similarly, another example HOH, where O is more electronegative when compared to hydrogen. Because of that reason, this bond pair of electrons, they go with this OH, and we will get OH minus ion, and this H becomes the positively charged ion. Similarly, another example, let's consider this one, HBr molecule. In this HBr molecule, the bond pair of electrons, the covalent bond, single covalent bond, which has two electrons. These two electrons, they both go with the bromine atom. We will get Br minus ion and H plus ion. Here, the bond fission is taking place heterolytically. That is unequal distribution of electrons. Homolytically in the sense equal distribution of electrons. Here, unequal distribution of electrons is taking place. That is only one atom from the bond pair. No electron is involved in with this atom. So this is how heterolytic bond fission takes place. And next, let us say the differences are the comparative study of heterolytic bond fission and homolytic bond fission. That is two types of bond fission. Comparative study, let us consider. So we have already discussed what is meant by bond fission. Bond fission is defined as the breaking of existing bonds in the reacting molecules. This bond fission is two types we said there. The first one is homolytic bond fission and second one is heterolytic bond fission. Now here let us see the homolytic bond fission. In the homolytic bond fission, if the bond pair of electrons, they go with both the bonded atoms, then it is called homolytic bond fission. If the bond pair of electrons, the bond pair of electrons goes with any one bonded atom, then it is called heterolytic bond fission. So the difference between this and this is, here the bond pair is equally distributed, here the bond pair is unequally distributed in between the two atoms. And next one is distribution of free radical. What is a free radical? We said free radical is nothing but atom or the group of atoms, or it is also called species with odd electron or unpaired electron or single electron. And this heterolytic bond fission results in the formation of ions. So what are the ions produced? We said two types of ions produced here. One is positively charged in this heterolytic bond fission are known as electrophiles, and the negatively charged ions produced during the heterolytic bond fission are called nucleophiles. Now, third one is this homolytic bond fission. It takes place when two bonded atoms have same electronegativity, whereas heterolytic bond fission takes place when two bonded atoms are having different electronegativities. This is about the differences or comparative study of two different types of bond fissions. Here in the organic chemistry, we come across three types of organic reagents. They are first one is free radicals, second one is electrophiles, and third one is nucleophiles. So there are three types of organic reagents, is it? There, the first one is free radicals, second one is electrophiles, and third one is nucleophiles. So let us discuss about all these organic reagents one by one in detail. First one is about free radicals. So free radicals are the substances That is, either atoms or the species. Species in the sense group of atoms which contain an unpaired electron or single electron or odd electron. So free radicals are defined as the species which contain an unpaired or single or odd electron. These free radicals are generally produced from homolytic fission that we have discussed yesterday. Free radicals are produced by the homolytic fission of the covalent bond present in the organic compounds. And these free radicals are highly reactive because they have odd electron and they are short-lived. Why they are short-lived? Because they immediately combine with some other atom or species to form the compound. Because of that reason, they are highly short-lived. At the same time, they are highly reactive as they have odd electron with them. Next one is about the free radicals. They attain stability by a chemical change during their lifetime. That is, immediately once they are formed, they attain stability by participating in the chemical reactions. Now let's discuss the different examples which we come across for free radicals. There, the first one is atoms like chlorine, hydrogen, bromine, etc. If this chlorine atom contains one electron, that is odd electron or unpaired electron, then it is known as chlorine free radical. Similarly, hydrogen free radical, this one. And this is bromine free radical. Bromine with an odd electron, hydrogen with an odd electron, or chlorine with odd electron. These are known as free radicals. That is atoms with unpaired electron. And sometimes a group of atoms also contain unpaired electron. Example, they are called species. Group of atoms that is known as species. The species like CH3 dot. This is C2H5 dot. CH3 dot is known as methyl free radical. Methyl, methyl, methyl free radical. And this is known as ethyl free radical. This is called ethyl free radical. C2H5 dot. Dot is nothing but an electron. Similarly, sometimes neutral species having unpaired electrons or single electrons also act as free radicals. Neutral species, that is, they do not contain they do not contain single electron. No, they are not the charged species, but in the structure, this is a neutral molecule, but in the structure they contain unpaired electron. Because of that reason, they act as free radicals. Example, NO and NO2. If we consider the Lewis dot formula of NO and NO2, they reveal that they contain unpaired electron. If we consider the Lewis dot structure of NO or NO2 molecule, there we will come across the unpaired electron. Because of that reason, they act as free radicals. So free radicals are the species which contain an unpaired electron or odd electron or single electron. There they are classified into three types. First one is atoms with unpaired electrons, second one is species with unpaired electrons, and third one is the neutral molecules with unpaired electron. They also act as free radicals, we said. And next one is about the electrophiles. The second type of organic reagents is electrophiles. So what are electrophiles? Electron-seeking agents are called electrophiles. Electron-seeking and electron-liking or electron-loving agents are called electrophiles. Here, electro means electron and phile means seeking or liking or loving. The one which likes electrons is called electrophile. Hence, the definition can be given like this. The electron-seeking agents are called electrophiles. And in general, electrophiles are electron-deficient compounds. Electrophiles, they contain less number of electrons than the octet in the valence shell. Because of that reason, they are electron deficient compounds and they undergo reactions with high electron dense compounds as they do not as they lack in electrons. Because of that reason, they combine with the compounds or the species having more number of electrons or electron-rich compounds. So, in general, electrophiles are electron-deficient compounds and they undergo reactions with high electron-rich compounds. Next one is electrophiles are formed in heterolytic bond fission of a covalent bond. Yesterday we discussed about the types of the bond fission. There homolytic bond fission and heterolytic bond fission. Homolytic bond fission produces free radicals, whereas heterolytic bond fission produces ions. Their positively charged ions are called electrophiles. So electrophiles are formed by the heterolytic bond fission of a covalent bond. Heterolytic bond fission in the sense the bonded pair of electrons they go with any one of the bonded atoms. Because of that reason what happens, one atom gets the positive charge, the other atom gets the negative charge. So the positively charged ion is known as electrophile. Now let's consider the examples of electrophiles. Here first of all, let's discuss about the positively charged ions or cations. So the positive ions or cations, they act as electrophiles because they are electron deficient. The positively charged ion, the ion which possesses a positive charge on it, it is electron deficient. Because of that reason, it acts as an electrophile. Now let's consider the examples. H3O plus hydronium ion, Cl plus chloronium ion, Br plus bromonium ion, H plus. Hi, this is proton. NO plus nitrosonium ion, NO2 plus. This is nitronium ion, nitronium ion. So these are all the examples, different examples of electrophiles. So electrophiles are the cations which are electron deficient. That is, these are the compounds or the species or the ions which have positive charge. They possess positive charge and they are electron deficient compounds. Because of that reason, they are called electrophiles. Electrophiles. And next one is positively charged alkyl groups are generally occurred in organic reactions. So here we consider the positively charged ions, but here no carbon is present. But in general, organic chemistry, we come across positively charged carbon compounds. These positively charged alkyl groups, generally alkyl groups, positively charged alkyl groups we come across in organic reactions, and these positively charged alkyl groups are generally known as alkyl carbonium ions or alkyl carbocations. That is, the carbonium ion is nothing but the ion in which carbon bears the positive charge. The ion in which carbon bears the positive charge is known as carbonium ion or carbocation. So examples for this carbonium ions R plus, RCO plus. This positive charge should be on the carbon atom. Okay. So example we have given, that is methyl carbonium ion CH3 plus. C2H5 plus also we can give, that is ethyl carbonium ion. Ethyl carbonium ion. So like this, these are the compounds in which carbon possesses positive charge. Because of that reason, they are known as carbocations or carbonium ions. Okay. Let's see the. Sometimes instead of positively charged ions, sometimes neutral electrophiles, neutral molecules also act as electrophiles. So Lewis acids are electron deficient compounds. Lewis acids are electron deficient compounds. Electron deficient compounds in the sense octet incomplete compounds. They act as electrophiles. They also act as electrophiles. Previously we discussed about the positively charged ions which act as electrophiles. But here, neutral molecules, they also act as electrophiles. Generally, these neutral molecules are called Lewis acids because they are electron deficient compounds. Electron deficient compounds in the sense, the valence shell of the central atom octet is incomplete. That is, 8 electrons are not present in the valence shell of the central atom of that species or molecule. Then it is known as electron deficient compound. So, sometimes neutral molecules also act as electrophiles. So in these compounds, the central atoms attract the electrons because they are electron deficient. And these are neutral compounds and accept electrons. These are the neutral compounds as they lack in the octet in the valence shell. Because of that reason, they accept electrons. Examples for such type of neutral electrophiles are BF3, boron trifluoride. In the boron trifluoride molecule, boron atom is the central atom. Surrounding boron, 3 fluorine atoms are present. That is, around boron, only 3 bonds are present, 3 covalent bonds are present. That in that sense, so, boron has only 6 electrons in the valence shell. As boron has 6 electrons in the valence shell, it is electron deficient because octet is incomplete. Octet in the sense 8 electrons. But in BF3, in the valence shell of boron, only 6 electrons are present. Because of that reason, it is having 2 electrons less than the octet. That is, it is an electron deficient molecule. Because of that reason, BF3 acts as an electrophile, which is a neutral molecule but acts as an electrophile. Now let us consider this one. AlCl3. Similar structure, it will be having the similar arrangement of electrons, and this AlCl3, it also acts as an electrophile, neutral electrophile. And other examples, if we consider this SO3 molecule surrounding sulfur, the central atom is sulfur. Surrounding sulfur, only 6 electrons are present in the valence shell. Because of that reason, this SO3 molecule also acts as an electrophile. Lewis acids are octet incomplete compounds and generally accept electrons. So electrophiles also have the same nature. Because of that reason, all electrophiles are called Lewis acids. These are represented by the symbol. Generally, electrophiles are represented by the symbol E or E plus. E in the sense electrophile. This is the first letter of electrophiles, and sometimes we also represent electrophiles with a positive charge. E with a positive charge. This is about the electrophiles. Next, third type of the reagent, organic reagent, is nucleophiles. Nucleophiles. So nucleophiles. Here nucleo means nucleus, phile means loving or liking or seeking. Ishtapadedi. The one which likes nucleus and a positive charge is called nucleophile. So nucleus seeking agents are called nucleophiles. That is, the one which likes nucleus is called nucleophile. Nucleus in the sense, generally we know nucleus is positively charged. So the one which likes positively charged center is known as a nucleophile. Next one is, so nucleophiles, they attract a nucleus or positively charged centers. They donate electrons to other substances because nucleophiles, they have excess of electrons. Nucleophiles are formed in heterolytic fission of covalent bond. We have already discussed heterolytic bond fission yesterday. And the heterolytic bond fission, what happens? We will get 2 types of the ions. One is positive ion and the other one is negative ion. And positive ion is called electrophile and negative ion is known as a nucleophile. So what are nucleophiles? We said nucleophiles are nothing but nucleus seeking, nucleus loving, nucleus liking reagents. So nucleus seeking agents are called nucleophiles. This is the definition we can give. And so nucleophiles, they generally attract a nucleus. Nucleus in the sense the positive center or positively charged centers. Generally, these nucleophiles, they have excess of electrons. Because of that reason, they donate electrons to other substances. They have the ability to donate electrons to other substances as they have excess of electrons. Next, nucleophiles are generally produced in Heterolytic fission of a covalent bond. We have already discussed about this heterolytic bond fission. Now let's look into the examples of nucleophiles. Examples of nucleophiles. Negatively charged ions or anions. One type of nucleophiles, negatively charged ions or anions. So these are electron excessive and they can donate electrons. So negatively charged ions, generally they possess excess of electrons. Because of that reason they can donate electrons readily. So these are the nucleophiles which have excess of electrons with the negative charge. Now examples, let us consider Cl minus chloride ion, Br minus bromide ion. Next one is I minus. This is iodide ion. This is hydroxide ion OH minus, Cn minus. Like this we can give many number of examples as nucleophiles. Any negatively charged ion acts as a nucleophile because of excess of electrons as it can donate electrons. Next one, negatively charged alkyl groups are also called negatively charged alkyl groups. They also act as nucleophiles and they are generally known as carbanions. Anion means negatively charged. Carb means carbon. So carbon containing negative charge. The ion in which carbon possesses carbon bears negative charge is called carbanion. Here let's consider the example. This one. Alkyl carbanion R minus. Alkyl carbanion. This is alkoxide ion. This is carboxylate ion. So carbanion means the anion means negative charge, carb means carbon. So the ion in which carbon bears negative charge is called carbanion. So previously we studied about carbocations in electrophiles. Here we are studying about carbanions in nucleophiles. Nucleophiles, carbon bearing negative charge is known as carbanion. So these are they also act as nucleophiles apart from all simple negative ions like chloride ion, bromide ion, iodide ion, etc. Now next, other examples of nucleophiles. In the other examples of nucleophiles, sometimes neutral molecules in which lone pairs are present on the central atom can act as nucleophiles. So, apart from negatively charged ions, neutral molecules with lone pairs of electrons. Lone pair means the pair of electrons which does not participate in the bond formation is called lone pair. So, the neutral molecules in which lone pairs are present, they also act as nucleophiles. So, excess of electrons are present in that molecule. Therefore, it acts as a nucleophile. So, in general, they are octet complete substances. So, in neutral molecules, they are having completely filled octet, but a pair that is a lone pair is present which is not participating in the bond formation. Because of that reason, that lone pair is available for the donation. Because of that reason, these neutral molecules with lone pairs, they act as nucleophiles. So hence they donate electrons to other substances as they have excess of electrons. And the following types of substances act as nucleophiles. So what are the different types of substances that act as nucleophiles? Let us see. So, neutral molecules in which lone pair of electron is present on the central atom act as nucleophiles. So, neutral molecules with lone pair. Now, let's see the example. Here is the example. H2O. On oxygen atom, two lone pairs are present. So, whenever only one lone pair is enough, then it acts as an axial nucleophile. Here in ammonia, nitrogen atom contains one lone pair, therefore it acts nucleophile. Similarly, ROH is nothing but alcohol. In this, oxygen has two lone pairs of electrons, therefore it acts as a nucleophile. Similarly, ROR is the general formula of ether, so you know, I think. So here the central atom is oxygen. On oxygen, two lone pairs will be present. Because of that reason, this ether also acts as a nucleophile. So these are all the neutral molecules. These are all the neutral molecules in which the central atom of these molecules, it possesses either one or more than one lone pairs of electrons. Because of that reason, these molecules, they act as nucleophiles. So what are all the examples we said? Water molecule, ammonia molecule, alcohols, ethers, etc. They act as nucleophiles, which are neutral molecules with lone pairs of electrons. Next, generally, we know that electron pair donors are called Lewis bases. Electron pair donors are called Lewis bases. Therefore, nucleophiles are also electron pair donors and hence they are called Lewis bases. We just now studied their electrophiles are Lewis acids, we said, because Lewis acids are the substances which accept electrons or electron pairs. Lewis bases are the substances which donate electron pairs. So here nucleophiles are the substances which are electron pair donors. Because of that reason, they are known as Lewis bases. Electrophiles are Lewis acids and nucleophiles are Lewis bases. This point we should remember. They are generally represented by these nucleophiles are generally represented by either Nu or Nu minus. Nu nucleophile or Nu minus also used to represent nucleophiles. Okay, thank you students. We will continue with the next topic in the next session.